In this video, we are going to go over how to add integers that have different signs. So meaning we are going to add a positive number with a negative number, or flip it around and add a negative number to a positive number. Let's jump into a couple of examples that will go in depth as to why this system of thinking works, and then we'll employ or use that new way of thinking to solve out a letter C and D and talk about a special kind of problem in E. So in this first problem, we're told to add -3 plus 5. Well, and as far as a number line goes, that means go to the left 3, right? So we're going to go left 3, like that, get to -3, and then go to the right 5, add on 5. So I'd go to the right 1, 2, 3, 4, 5. And I'd end up right here at 2. So our answer, according to a number line, is 2. So what is this system of thinking that we can use? Well, the trick, so to speak, that you're going to hear possibly in your classroom or in other areas of learning is when you have two different signs and you're adding, you subtract the numbers and take the sign of the larger number. So mentally, this is not the work that I would show, but mentally I'm doing 5 minus 3 is equal to 2, and I'm looking at these two numbers and I think 5 is the larger of the two numbers and it is positive, so I take the sign to be positive. All right, so that's the trick. Why does it work though? Well, if we think about this, we've started out going to the left 3. We then go to the right 5. In going to the right 5, we've erased our loss of 3 right here. Right? We've added back 3. And how much more do we have left over? We have 2. Now that spot right there, that is the difference between 5 and 3. It is the difference in how much more positive that 5 is compared to -3. And the difference means we should subtract them, right? That is the reasoning behind why you subtract the two numbers without thinking about their signs and take the sign of the bigger number. So rad. All right, let's employ that technique here and support it again with one more number line problem, and then we'll do a couple without a number line. Okay, this says 2 plus -7. So with the number line, I would start at 2, so I'd go over 1. Ooh, not start at -1. Oh boy. All right, let's start that at 0. So we start at 0 and go over to 2. So here we are at 2. Then this tells us to go to the left 7. So I'm going to go to the left 1, 2, ooh, I'm going to go back to that part in a second, 3, 4, 5, 6, 7. And we end up here at -5. So our answer according to the number line is -5. Now I'm going to do out this kind of mental thinking we did in the last problem, which is take the difference of the two numbers without thinking of their signs. So I'm looking at this as 7 minus 2 is equal to 5. That is their difference between the two numbers. Some people will say take the difference of the absolute values of the numbers, right? The absolute value of -7 is 7. The absolute value of 2 is 2. Their difference is 5. Now, we then take the sign of the larger of the two numbers. The larger number is 7. It's farther from 0 than 2 is. So that has a negative sign, so our answer is negative. So again, you take the difference of the two numbers without thinking of their signs, keep the sign of the larger number. 7 minus 2 is 5, it's -5. A quick reminder of why that works. Well, I got a little excited here. We went to the right 2, then going to the left 7, we had erased all of our gain when we got to 2, right here. So this was a -2 at this part. We still had 5 more to the left to go. Or the difference between 7 and 2, which is more to the left, and therefore we get -5. That is so cool. I love it. I love when we can see the reason why behind these rules. All right, now we're going to use the rule in C, D, and in E, and we'll call it a video. 10 plus -7, we are adding two integers with opposite signs. So in my head, I'm going to do 10 minus 7, right? That's in my head, and that is equal to 3. Well, the larger of the two numbers in terms of their distance from 0 is 10. So I will keep the sign of 10, which is positive. So 3 is my answer. Here we've got 8 plus a -9. So again, mentally, I'm doing this. I'm doing 9 minus 8. I'm taking the difference of the two numbers without thinking of their signs. That's 1. But 9 is a larger number than 8 is in terms of its distance from 0. But it's to the left 9. So negative, sign of the larger number right there. And again, you can remind yourself if you ever forget these rules, I'm going farther to the left than I am to the right here, and therefore the difference of how much farther I'm going to the left is 1. Left 1, -1. Awesome. Okay, the final problem here, you can do this in a number of ways. Anytime I add 0 to a number, that number stays the same. So you could think of it that way. Keep it as -7. That's known as the additive identity or the addition property of 0. Or you could look at this and say, well, I'm going to take the difference of the two numbers mentally, 7 minus 0, and then I'm going to keep the sign of the larger of the two numbers. 7 is farther from 0 than 0 is, so -7 is the sign that goes with the larger number. That, peeps, is adding integers with different signs. I hope you enjoyed it. I love teaching this stuff.